and I'm going to start the broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. My name is Ara Ashikian. I'm the product manager for Bridge Design for InfraWorks 360. Can you all hear me correctly? Charlie?
Yep, we can hear you fine.
Okay, so today is a new installment of the InfraWorks webcast that you have a chance to interact with the product team, and we will walk through an introduction of how bridge design is handled in InfraWorks. And we'll walk through some simple scenarios, and all the way, feel free to ask some questions. We have our product team online awaiting all your questions. So once again, this is in the webcast series, and it happens the first and third Wednesdays of the month. And the goals are to inform you about the InfraWorks 360 features from the product team, give you a chance to ask questions and provide feedback, and bring us all together. Heads up, what's coming up in the next webcast, slated for June 17th, is what's new in InfraWorks 360 for the June release. And again, we will have the product team on hand to go over all the exciting new features. We also have a number of topics for future webcasts, and they are listed on the screen here. So we have InfraWorks has a vast number of capabilities, and we want to see what the interest is in the prioritization of the webcasts. So Charlie's going to start a poll here and take a minute or so to reply. I think there's 2 questions in the poll. Charlie, go ahead.
All right, the poll is up. All right, I'll close this poll. And then there's a second poll about everybody's current usage level of InfraWorks. We'll just give a moment for that. All right, it looks like most people have answered that. I'll close that second poll.
Thanks, Charlie. Also, we wanted to mention that we have the InfraWorks 360 community web pages. There's forum feed, there's galleries, there's videos, there's recorded webcasts. And we also have this website called the InfraWorks 360 Idea Station. And this gives you, the end users, a chance to suggest features or wish lists and have all of you comment on all of these requests, and have the product team involved as well. And if you can generate some excitement on some requested features by your peers, all the better chances of us including that in our prioritization. So we certainly invite you to take advantage of this idea station. Now, before I embark in the presentation, while most of the presentation is going to be focusing on the release, the June release, the 2016.2, at the end we will be showing a few features that are upcoming in future releases. At any time, the presentation, we're not making guarantees of some of these features being available at a certain time. We want to show some of the direction and get some feedback, of course, but it is not meant as a promise for the future. Keep that in mind. So this is a common disclaimer that you will see in all the webcasts. And again, ask a lot of questions. We are here to answer them. So here we go, inside bridge design for InfraWorks 360. And I'm going to switch over to InfraWorks now. And because of the lag and screen over the internet, I'm going to avoid moving around too much. But here is a InfraWorks 360 model. So what does that entail? InfraWorks 360 provides a in-context model so that you can see your project within the site model, aerial imagery, terrain elevation. You can also have LiDAR, all sorts of things to give you context. And we talk about it all the time. You design in context. Here, I quickly put a design road that's crossing this this highway. And in today's presentation, let's have a look at what does it mean, or how do you actually model a bridge in context. So let's first of all select the road that's in front of us, and we will go to the toolbars at the top, and we have this bridge toolbar, and under the design mode we have two options. We can do precast eye-girder bridges, or we can do steel plate girder bridges. Let's do a precast eye-girder bridge, and you can go hover over the bridge, over the road, and place the bridge, where you want it to fit in the model. So let's just drag it over, say something like this. Now, it's a rules-driven system, so when you place a bridge, InfraWorks tries to use reasonable assumptions that you as an engineer can modify as to, based on the span to depth ratios, which type of precast girder is suitable, or how many girders make sense, that an experienced bridge engineer would use. The model is in context. We can look at, for instance, let's look at the clearance envelope here. Let's maybe align it with the road. Now, suppose we decide here that we want to actually hire a clearance envelope for whatever reason. I'm gonna change the clearance envelope, and in this case, we could go into the road, select the road, and change its vertical profile, or go in profile view and manipulate it. But we can simply click on the bridge and say, oh, let's update the bridge's vertical profile so it respects the requirements of the clearance envelope. So here, this is just the starting steps. Let's turn that off for now. Now, it's not just graphics. When we created the initial model, so we have, in this case, the default is precast eye girders. And let's turn off or toggle on deck transparency. We can have a better look at it. So we have a series of precast eye girders. If we want, we can go and view the quantities. So while you're modeling, InfraWorks is keeping track of all the key quantities for you. So if you change the number of girders, if you change the pier dimensions or layout, if you change the number of spans, if you change the type of girders, it's constantly recomputing all these quantities. So they're available for you, and they're divided into main categories: the precast versus cast-in-place concrete or structural steel, for the bridge as a whole, or for the superstructure versus the substructure, or if you select a specific element of the bridge, you can get its own breakdown. So that's always there, very handy. So you're modeling in context. It's keeping track of some of this information. It's rule-based so that a starting point is reasonable. So I'm going to turn that off for now. And again, let's turn off the clearance envelope. And so here the pier isn't really quite where it should be. Or in fact, this first abutment, maybe we can pull the bridge in a bit. So once you place a bridge, you can always come back and manipulate it. So we're going to drag on this bridge gizmo and update the start of it. We're going to take this, maybe let's also skew this abutment. In fact, this abutment is fully parametric as well. So if we were to go and put some terrain transparency on, we can see some of the abutment. It's a wind wall abutment in this case. Let's go in here and parametrically just change it a bit. In fact, we want to have an abutment that's acting as a retaining wall system as well. So let's put extend the wind walls out a bit, and let's do that on both sides. So we can see the abutment a bit better now, and we can go in here and skew it so it aligns with the main road that it's crossing a bit better. We could also go in here and lengthen the wing walls. Let's say we make it 12 meters long on both sides, and let's make it go all the way down to the ground, so it's acting as a full retaining wall. So we could go in here and say it's something like 7 meters deep. Now, an important thing to mention here is this is a parametric abutment, and we can click on it. You can see a larger image of it. But the parametric content, you as end users in the future will be able to add to it. So we have a product called Project Chameleon, which is provides content at the moment in InfraWorks for all the drainage structures. In the future, it's also going to be made public so that bridge designers can add their own content, whether it's all sorts of abutments, piers, foundations, and many other bridge components. They all become fully parametric, and they expose their own dimensions. You as a content author can create as fancy as you want or as simple as you want, and you have full flexibility. So the modeling is going to be open. The in-canvas experience is going to remain, and you continue interacting with the model in an intuitive way. Here we're going to move this pier so it's a bit better aligned. We're going to also select the gizmo here and skew it. Now you'll notice the piers always are adjusting to match the skews and the offsets that you're creating for the abutments or piers. In this case, let's also shorten this this bridge. There's no need to have this abutment all the way out there. We can tuck it in a bit closer to the, in this case we have this side road that's coming in. So we have here, just a few minutes, creating a model in context where we look at the constraints of the site, of the roads that we're crossing, the possible locations for piers, and playing with all the different variables. Now, if we go on to the superstructure, we can see here the concrete girder group asset card, and it's indicating that by default it came up with an Asheville Type 4 girder. You can go in there and really you have a pretty comprehensive library of sections that you can choose instead of that. So if you wanted to have an Australian type of super T girder, you could switch to that. In different locations around the world, there are different common practices. I just switched the exterior girders to have this super T cross section. It could be something else as well. So you have, again, in the same way that you will in the future be able to add your own piers, abutments, and parametric foundations and so on, you can also in the future add your own girder geometries, and they will also be parametric. You can at any time undo what you did. So you have all those capabilities. You can also, when you select a girder group, you can select a specific girder, see its individual length. You could play with the lateral offset for each girder individually, so you can model more precisely what you're looking for, or at the group level, just play with the spacings between the girders. Now, if we go at the bridge level asset card, we can play with the continuity of the piers. At the moment, it's set that the deck is continuous, or the reinforced concrete deck is continuous, but the girder is simply supported. So we have essentially two bearing lines over the pier. We could also say, well, we want to have a continuous system where the deck and girders are continuous. Now we make that change, and it's going to update the model for us. We could keep it fully simply supported. If we were to delete this pier, it resulted in deeper girders and changed the girder size, so it respects a bit better the span to depth ratio. We could also take this model into Civil 3D, so the whole InfraWorks model or parts of the InfraWorks model. And in the last webcast, Charlie and Tim were showing how you can select in InfraWorks and have it exported to Civil 3D, where you can do detailed civil drawings. In the future, this same workflow will also be available, so you can take this bridge and into Revit. And in Revit, you would be able to do more structural drawings, construction details, add rebar to concrete components, and so on and so forth. So that's something that's coming up in a future release. Now, we spent a few minutes here when we created this bridge. We made sure it's tucked in nicely with the site. We looked at the clearance envelope. We looked at the abutments and skews and so on. And now it proposed different girder sizes based on reasonable proportions. And we can take that a bit further. And if we select a bridge, we can go into this toolbar and this option called Line Girder Analysis. So this is the first of a number of cloud services that we will be offering for bridges and structures in the future. And what this allows you to do as an engineer is select your bridge and use the power of the cloud to assess, do an analysis and code check to validate your pre-stressed girders. Now, before we go straight into that, let's look at the bridge asset card here. You have different design standards you can pick from. Now, this is leveraging a very powerful product called Autodesk Structural Bridge Design on the cloud. Autodesk Structural Bridge Design has been around for many years, and it's very well known for very detailed analysis and design and code check of highway type bridges in great detail. And it supports a number of international design standards, including AASHTO and various Eurocode standards, flavors. So let's stick with the AASHTO code here, and we select the bridge, and we can go and say start an analysis. Now this will trigger a cloud service, and it will look at all the girders all at the same time in the cloud. And when it's done, it's going to highlight all the girders. So this line girder analysis is a beam line analysis. It's the first of many bridge analysis services. So line girder analysis essentially is a beam line where it determines all the moments and shears along the bridge, and then uses design standard-based lateral distribution factors to establish all the moments and shears to all the girders. When you run line girder analysis, it's also going in and determining for you how many pre-stressing strands you need, what type of pattern works to meet all the different requirements of the design process. And while you're doing this, you're invited to, you can run it, you can look at results, you can move piers around, change the number of girders, change the girder styles, change deck thicknesses. Just play around with it. As an engineer, bridge design is an iterative process. We want the users to experiment with the model, and you can view high-level results at any point. And then when you're satisfied with the design, you can use cloud credits in the future and get fully detailed reports of all the calculations leading up to this model. In addition to that, you can launch from InfraWorks for this specific bridge Autodesk Structural Bridge Design if you have that software, and roll up your sleeves and look at the model in greater detail and play with a number of other parameters that we don't expose yet in InfraWorks. So it makes the whole process very convenient. Now, in light of the time and the fact that I have other things I want to walk through, I'm going to just pull up from a different proposal the same or similar bridge where I actually did run the cloud service. It can take 5-10 minutes or so on typical bridges, but here we have results. Now I'm going to rotate a bit more. You can see in this case the girders are color coded. If you hover over the girders, the results or the dominant or governing clause is highlighted. In this case, live load bending serviceability for positive bending is governing, and if you hover over all the girders, you can see. Now, if you were to select this specific girder, click on it, you would get this high-level summary of the design checks that it carried out. So pre-stress transfer, erection stage, construction stage, that's in the casting of the deck, and live load bending, positive and negative, and so on, and the shear capacity. And this is what I was talking about earlier. You can go then just hover around, click on any specific girder, and view its high-level results, and make changes to the bridge. And when you're satisfied, you can go and get the full report. In the future, this will entail using cloud credits. For some reason, are you guys able to see the calculation report on the screen? It pulls up a...
We just lost your screen. Screen is black.
Yeah, okay.
Oh, there it goes.
It's back to InfraWorks now, right? Okay, here we go. So this is the report that it created. I guess GoToMeeting didn't transfer over to the PDF view nicely. So when you carry out line girder analysis, then it creates a very detailed report. And you can see for this girder the pattern of strands that works, all the key stresses. And if you were to hover through it, you would see all the key diagrams, in this case live bending, and all the design calculations and clauses that were used in great detail. So all the equations that were used. So Autodesk Structural Bridge Design has very detailed documentation and you will get this for all the girders of the bridge. You can jump over to overall diagram views or modeling aspects, how the line girder analysis was created, and save this with your project for future reference. When you create models in InfraWorks and you do line girder analysis, it will store this bridge along with its results once you purchase all the calculations in a proposal. So if you were to go back and make further changes to this bridge, you can always then access this previous run in a proposal by going up to the InfraWorks proposal menu and picking that. So we really invite the users to try many different ideas, experiment, look at calculations. In the future, these cloud services will go beyond line girder analysis and include grillage analysis, so you have a 2D analysis of the deck system where you can account for effects of skew or curved and planned girders and so on a bit more efficiently than using design standards for lateral distributions. We will take that even further in the future with finite element models that we will extract from the InfraWorks bridges for more detailed assessments. I'm going to close this off. So that's InfraWorks 360 as you have it in the upcoming June release, the current release. So it's the ability to design bridges in context, play with all the parameters of the bridge. I didn't spend too much time on foundations. You could play on with the foundations, change the number of piles, and so on and so forth, and get your quantities, get your analysis results. And let's close this off. I'm going to load a work-in-progress version of InfraWorks just to show some of the things that are coming up, how we plan to extend this parametric modeling approach further with piers and foundations. And again, no promises as to the delivery of this, but we thought in today's presentation we would like to show you what we're talking about. At the moment, the cloud service for the line girder analysis is for pre-stressed concrete girders. In the future, we will be expanding the steel girder modeling capabilities of InfraWorks and updating the cloud service for that. So here we have a model of Devil's Slide in California. And let's suppose that we were lucky enough to win this project to design this bridge that's the coming off from the Devil's Slide tunnel and joining the main road here. So let's zoom in a bit here. I just placed a road in here, and we want to add a bridge in this location. So once again, let's go into the bridge menu or toolbar, and in this case, let's try a steel girder bridge. So let's again, you just place it where you think it should go. You can always adjust the locations. So it came up with a configuration based on this bridge length of almost 250 meters we came up with this configuration. What if we wanted to be a bit more daring? Now, the steel plate girders, you can see they're kind of a weathered steel design, and they're continuous. You can see that you have different segments continuous segments over the piers and splices in between field splice segments. What if we wanted a more daring design with fewer piers? Let's say even just 2 piers. We can just go in and change the number of piers. Whoops, no, I changed the wrong asset card here. Hold on. Let's select the bridge and change its number of piers from 4 to 2. You can see something interesting happen. The design rules behind the scenes recognize that for the corresponding spans, the user prefers to go variable depth plate girders when, in this case, the spans are over 80 meters. The default bridge that it creates is has haunch steel plate girders. So you could carry on experimenting with steel plate girders. Let's switch back to, you can go in here and bridge asset card and switch back to precast eye girders. There will be other bridge types coming up in the future. Today's versions are focusing on these. So here we have maybe a second alternative. So maybe you have a steel plate girder option, and you also want to consider a concrete bridge option. Now, when we have these kind of default piers, maybe you don't like those piers, or maybe you want something which is a bit more architecturally elegant. You can define or pick from the catalog that you can, in the future, add to any number of pier types. Let's say we want a pier that has curved pier cap. So it's a kind of a more organic pier shape. You can see that. Or let's say we want, what's common in California is these flared piers. You can just select those, and if I highlight, you can see the shape a bit better. So these are octagonal flared piers. In fact, if you zoom in a bit better, a lot of the bridges in California have this detail of notching in the column base, and even in this case, this is again a work in progress integral pier. The bearing shouldn't be there, but you can see here that you can have polystyrene at the very top, so you have a bit less stiffness at the cast in place joint. But you can then select this pier and say, well, this is a fully parametric pier. The InfraWorks itself doesn't need to know the inner details. It can be, you can really come up with very creative piers and towers and details. It exposes for you the parameters that are relevant in this case. Let's say we want to make the flared top a bit wider. So it exposes a pier cap width field for us. Let's make that 8 meters, and let's make the length over which the flare goes a bit longer, so it's a bit smoother. And here you go. You have just a few mouse clicks. You've changed this. And in fact, let's go in here and say we want 1 pier column instead of 2, and yeah, let's see what that looks like. 1, and let's make the section of the column a bit bigger. So here we go. We switch with a few mouse clicks to, let's make it a bit wider, 3 meter. 3.5 meter diameter. You can really experiment with your design. Now, you could then go in, all the while you're doing this, remember, all the quantities are being updated for you. And you can focus on the actual layout of the bridge or the assessment of the bridge and let InfraWorks do a lot of the computation for you. Let's say, in this case, you wanted all the other piers to have the same look and feel. You want to respect the same flare height, but you want the rest of the pier to adjust according to its vertical height. Now, in the future release, you'll be able to select a pier or a foundation, for that matter, and quickly apply it to all the other components. So here you go. We have a pretty elegant looking concrete bridge with flared piers that you configured. In fact, I think we can do a bit better than 6 piers. Let's try to come up with a layout that considers 4 slightly longer spans, so it's less foundation work. Yeah, it's adjusting all of the details for you. In the same way that the abutments are parametric and the piers are going to be parametric and user-defined in the future, foundations have the same capability coming up. So in this case, we have a slightly different piled pier cap that we can, let's say, raise it a bit so we can see it better. Raise it to 3 meters. And maybe add a few more rows of piles. And if we look at this, we came up with a new foundation layout, and if we zoom in, you can see that it's a slope pile cap. Again, the point we're trying to make is use the InfraWorks in-canvas ability to model in context, move piers around, skew them to reflect all the constraints, and the actual complexity of the geometry is secondary, and it can be really as detailed or as simple as you want. All of this information will transfer over to Civil 3D and in the future to Revit. So it really opens up a lot of opportunity for creative bridge design, for intuitive bridge design. And let's go one step further here and assign this to all the foundations. And if we were to make the deck a bit more, or the terrain a bit less opaque, then we can see all of this. So let's take a step back and look at this. In a few minutes, what we have done is, in the first model, we went in and put in a typical highway crossing bridge, play with the geometry and the layouts, use a cloud service to do some validation. This cloud service determined all the moments and shares for us based on the geometry, computed an initial layout of tendons for each pre-stressed girder that matches or meets all the design requirements, in this case for AASHTO. Then we came over here and we added initially a steel bridge to this longer 250-meter long bridge and played with the number of piers, showed how the steel girders and the rules kick in and adjust all the proportions based on the user's preferences, and then carried on, switched over to a concrete bridge to show how you can really play with all the piers and foundations. Let's do one more thing here. If I select, let's make the deck transparent. For this type of pier, really you want either cast in place box girders. That's a future improvement coming up. Or let's, for now, switch over to pre-stressed concrete box girders. I'll just pick one of them here. Now, when I switch to box girders, it adjusted all the spacings for us so it makes sense. And let's suppose that we like this layout. Let's assign this to the entire bridge as well. So here we go. We have a pre-stressed concrete box girder bridge with flare pier columns. And then you can also go in here and change the actual, if you don't like this type of alignment or barrier system or lighting system, you can go in here and with the bridge asset card switch to really a number of configurations that you can create. And also, I haven't mentioned component-based roads here, but in the in InfraWorks you can use component-based roads where you can define lanes and sidewalks directly as opposed to using styles. So that's another option that's available. So that concludes the live presentation for the InfraWorks 360. I hope that you have a better idea of how you can use InfraWorks 360 and the bridge design capabilities to help you in your upcoming projects. And we invite more questions if you have any. Charlie, on your end, if there are no further questions, I thank everyone for attending, and I remind you that the next webcast coming up is what's new in InfraWorks 360 in the June release, a number of exciting new features. And once again, remember to go to the Idea Station and put your detailed wish lists so that everyone, including us and your peers, can have a say on it. Thank you, everyone, and we will see you at the next webcast.